You know that person at work, the one who's super helpful but maybe a little too helpful? The kind who ignores your direct instructions because they're absolutely positive they know a better way? Well, it turns out the most advanced AI models can do the exact same thing. And this isn't just a funny quirk, it's a critical, hidden risk that we're only now starting to wrap our heads around. So let's really dig into this. We expect AI to be precise, to follow our commands to the letter. But what happens when the instructions you give it, the evidence you provide, directly clashes with the mountains of data it was trained on? Does it listen to you, or does it fall back on its own common sense? That's the big question. Okay, look at this. Say you give an AI a very specific, maybe slightly unusual instruction. First, confirm the order, then place the order. But the AI, having seen millions of standard business processes, just kinda fixes it for you. It outputs the correct, standard procedure. Now, here's the crazy part. It hasn't made a mistake in its logic. It has deliberately overridden your command because it thinks it knows better. And this is the mystery we're unpacking today. To figure out what in the world is going on here, we're diving into this really fascinating study. Researchers basically decided to play detective. They set up this incredibly clever trap to see if they could catch these large language models in the act. Their method was just brilliant. They used business processes as their testing ground. You can think of these like step-by-step recipes that companies follow for everything. And because a lot of these are standardized, the AI has a really strong pre-trained idea of how they should work. It has an opinion, you could say. So the researchers cooked up 3 different versions of these recipes to test the AI. First, you have your standard by-the-book process. No tricks. But then, they created 2 deliberately wrong versions to act as bait. One where the entire process was just flipped backwards, and another where all the steps were just randomly shuffled. The big question was, if you feed an AI these weird, nonsensical recipes, what is it going to serve back to you? And this, right here, is where things get really, really interesting. When the AI was looking at these strange instructions, it had a choice to make. Does it trust the weird evidence it was just given, or does it go with its gut and revert to the standard recipe it already knows? The results were, honestly, kind of wild in their consistency. You give it the standard process, it generates the standard process. Okay, no surprise there. But when you give it the completely backwards process, it ignores you and generates the standard process. When you give it the jumbled, shuffled process, it does the exact same thing. It just kept defaulting to what it knew was right, no matter what. So here's the crucial takeaway. When the AI's internal knowledge went head-to-head with the explicit evidence you gave it, its internal knowledge won every single time, hands down. Its loyalty to the facts you provide is shockingly low, while its instinct to fall back on its pre-trained common sense is incredibly high. The researchers put it perfectly in their paper. They said the model faces this dilemma, right? Should it be a faithful scribe, just writing down exactly what you said, even if it looks weird? Or should it be a helpful editor, correcting what it thinks is a mistake? And as we've just seen, it overwhelmingly chooses to be the editor. Now, this behavior isn't just some random glitch. It's a specific, identifiable phenomenon, and the researchers gave it a name that just perfectly captures what's going on. They call it knowledge-driven hallucination. This is a whole different beast from the random, mixed-stuff-up hallucinations we hear about. This is a very targeted kind of failure, where the model's own massive library of knowledge is so powerful that it actively stomps on and contradicts the actual facts you give it in a prompt. The best way to think about it isn't really as a bug, but more like a feature, the AI's common sense that's gone into overdrive. It really is like that overeager assistant who's so confident they're right, they'll just fix your instructions without even asking, totally convinced they're helping you out. All right, so we have a name for it, but why is this so much more dangerous than a simple, obvious error? Well, the answer lies in something the researchers call the plausibility trap. What makes this so incredibly dangerous is that the AI's corrected output doesn't look wrong at all. It's logical, it's coherent. It is perfectly plausible. If you didn't have the original, unusual instructions sitting right next to it, you would never, ever suspect a thing. The error is completely hidden in plain sight. And that is absolutely terrifying when you think about these high-stakes fields. I mean,
Imagine an AI summarizing legal evidence, but just quietly ignoring a key unconventional detail because it doesn't fit the usual pattern. Or generating a financial report that fixes an unusual but totally critical transaction. This isn't just an inconvenience. This could be catastrophic.
Okay, so the problem's clear, and the stakes are super high. The next logical question is, can we fix it? Can we teach this overeager assistant to just be a little more obedient? The researchers actually tested this exact idea. It seems so simple, right? What if you just add a line to your prompt that says something like, hey, disregard your background knowledge and just rely completely on the input I'm giving you? Seems like it should work. And the results were meh, kind of mixed. The strict adherence prompt definitely helped. It cut down the number of these hallucinations from 47 cases to 23 across their tests. I mean, that's a pretty big improvement. It cut the problem by more than half. But it's not a silver bullet, not even close. Even when it was explicitly told to ignore its training and just stick to the facts, the AI still went off the rails almost half the time. And that tells us something really important. This behavior isn't just some surface-level quirk. It is deeply, deeply ingrained in how these models actually work. So does a bigger, more powerful model solve the problem? You think so. Researchers looked for any relationship between a model's size or power and its immunity to this issue. The correlation they found was basically a big fat zero. In fact, and this is the real kicker, they found something completely backwards. The top-tier models, the ones that are supposed to be the best and brightest, were often the most likely to do this. A model like Gemini 2.5 Pro, an absolute beast on benchmarks, was super prone to this knowledge-driven hallucination. It seems its powerful, well-formed internal knowledge actually made it less willing to believe strange evidence. Being smarter actually made it more stubborn. So after setting the trap, seeing the shocking results, and trying to find a fix, what's the final takeaway here? What does all this mean for how we trust and how we use AI going forward? Let's just quickly recap. We've learned that AIs can and will actively ignore facts if they clash with their internal training. This isn't a random glitch. It's a specific phenomenon called knowledge-driven hallucination. Its real danger is the plausibility trap, the fact that the output looks perfectly fine, hiding the error. And unfortunately, just telling the AI to be more careful isn't enough to fix it. This leaves us with a really critical question for the future of AI. The very thing that makes these models so powerful, this vast generalized knowledge, is also the source of a really subtle and dangerous flaw. So as we build ever smarter AI, the real challenge is, how do we make sure it also remains obedient?